Hi everyone. This is Mohammed from EA Global Summit organizing team, and I'm glad to welcome you all for EA Global Summit 2022. Firstly, thanks to everyone for your interest and joining us for this session. So this session is by Takeshi Koano, who is the founder and the CEO of Spark Systems Japan, and he is going to present us on how the traceability is a key to valuable model to achieve valuable solutions. So we will be muting all the participants throughout the session, and if you are having any queries during and after the session, please use the chat window to drop the questions to the speaker. So we will be reading out the questions and the speaker will answer during the Q&A session at the end. So to enable collaboration and communication with Takeshi and other EA practitioners directly after the session, we request you to visit the dedicated channel for the session in Microsoft Teams. So Takeshi and several other speakers have kindly accepted to stay in the channel to have an one-to-one discussions to answering your queries. So the link to the MS Teams channel will be posted in the chat window for your quick reference. If anyone is having difficulties on reaching or connecting to the teams, please reach out to us so that we will be able to like you can reach out to us on the chat window, or you can write us to registrations at eaglobalsummit.com so that our panelist team will take care of it further. So thanks again once for your interest for EA Global Summit 2022, and we are looking forward to a wonderful session. Over to you, Takeshi. So I'm just
Okay, thank you for introducing me. Please give
one.
me a screen. Okay. Maybe it's okay. So now, thank you for joining this session. I'll now talk about traceability, the key to a valuable model. But before starting my session, I'm very nervous because it's my first time to have a presentation in English, in Japanese, more than half an hour. So it's, today I'm very nervous. I hope I can proceed my presentation well. And first, this is today's agenda. At first, I want to introduce myself, and I want to share frequently asked questions in Japan about modeling tools, and I want to tell you why we need modeling tools. And today's main theme, traceability benefits and tips. And last, I want to share a problem in traceability and its solution. And my session is announced as 60 minutes duration, but maybe it's about 40 minutes. And I already uploaded this slide to the team channel, Sparx Japan channel. So please download the PDF slides if you are interested in my slides. First of all, I would like to introduce myself. My name is Takeshi Kono, and I'm CEO and founder of Sparx Japan. And when I started Sparx Japan in 2003, number of enterprise users in Japan was 71, and currently 70,000 users in Japan. So now there are many users in Japan. And my first enterprise architect was version 3, so I already use out of versions. And today, my network seems a bit unstable, so I will turn off my camera during this session. And okay. So at first, I'd like to share questions asked frequently in Japan. For example, so what are the differences between diagramming tools and modeling tools? Or is it enough to use a free diagramming tool or an office tool like PowerPoint to describe UML, SSML, etc.? Customers often ask these questions before they purchase Enterprise Architect. If you use Enterprise Architect to draw pictures, the answer of the second question might be yes. It is because just drawing pictures by Enterprise Architect is almost the same as diagramming tools. So we should use Enterprise Architect as a modeling tools. And this means we should receive the full benefits of Enterprise Architect. So here, so what are the benefits of Enterprise Architect and how to receive the benefits of Enterprise Architect? So here are some of the main benefits of Enterprise Architect. First, we can create diagrams in various notations such as UML or CCM. And moreover, we can use multiple notations in one model at the same time. And it is also possible to generate source files or Word document from our model. This means we can use our model in other ways. And in addition, we can use simulation to check the validity of our model. At the design phase, we can use simulation to verify it's our model, if our model can meet requirements. And in addition, Enterprise Architect has various facilities related to project management, such as workflow and discussion, or etc. So previous session, Thomas says a lot of things about these project management features. And we can also use tools such as Collaborate, WebEA, etc. to share our model easily. So we can also use a web browser to see the model and post comments by using these tools. But Tom announced a new feature for new version 16.1 to be able to use Enterprise Active by using a web browser. I'm excited to hear that. But anyway, but I think the most basic use is to visualize the specification and design of the target system or software by using some notation and creating diagrams. So we create different types of diagrams to visualize our specifications and design. Each diagram visualizes what we want to tell and share by placing elements on the diagrams. Usually, we create many diagrams, and there are relationships among diagrams. More specifically, elements in each diagram have relationships to other elements. For example, suppose you can change an element and these red circled elements. In this case, the change may affect other elements placed on other diagrams. So we must check and update related diagrams and elements at the same time. Here is one simple system example. The leftmost diagram here is a requirement diagrams, and the middle is a block definition diagram showing a logical structure, and the rightmost is a block definition diagram but showing a physical structure. We place elements on each diagrams, and there are relationships between these three diagrams. As I mentioned earlier, there are relationships between the elements placed on the diagram. For example, a requirement placed in a requirement diagram, there must be a block that realizes the requirement. And each logical blocks have relationships with a physical block. So physical block can be an actual device or software, and we determine to which physical block will realize the function of the logical blocks. So there are relationships like this. And as the number of the diagram increases, these relationships become more complex. In some cases, an element placed on a diagram may not relate to other elements on other diagrams. The elements may be unnecessary or isolated. So in this animation, this red circled elements has no relationships to elements on this diagram. So this element is isolated or sometimes not necessary. So this is a situation we cannot keep consistency for the model. So it is challenging to manage a large model with many diagrams properly. So how do we manage such complexity? Here is another example of a complex model. I created this diagram to introduce enterprise architect to Japanese customers. So I have a same model here. This is the actual model. And so it shows a typical flow, a general design flow. The top is a business layer here, business layer, and the second and the third is system and subsystem layer, and the bottom is a component layer. And so we create many diagrams to describe the target system, target specification and design. So there are various relationships among the elements placed in these many diagrams. So we cannot manage these relationships by diagramming tools. The diagramming tools cannot check for omissions or isolations. So I use this example to tell why a modeling tool is necessary. So because we need to create a lot of elements, a lot of diagrams. So can you manage by the diagramming tools? I think so. Traceability is a key to resolving such complexity. So traceability is information that shows how the elements in models are rated. So the following is a quote from Wikipedia that explains traceability. So traceability refers to the ability to link product requirements back to stakeholder rationals and forward to corresponding design artifact called and test cases, etc. So what are the benefits of traceability? Let me explain the main advantages. First, we can check if all requirements are realized by other elements. In some cases, an element realizing a requirement is also realized again by yet another element. We can verify all requirements are realized by traceability. We can check if there are no isolated and unnecessary elements in the model. And second, we can know why an element is necessary for the model. By using traceability, we can find requirements from an element, so we can know the element is necessary or not. We can see the impact of changes before we modify the source code. So directly changing the source code may cause unexpected inconsistencies, resulting in a new bug. When we cannot understand relationships among source codes when we change a source code, so we may check and change only what we know. So as a result, bugs may occur in a completely unexpected code. So here is an example. There are two source files here. These are source files. And now I will change this source file. So I changed the source file. But actually, there is a relationships like this. So this source file is implemented of this object, and this object has a relationships like this. So that means these two files are connected. So when we want to change this source code, we must check and sometimes update these files because they are related. So traceability is necessary for during describing the specification design. Sorry, and this text is under this picture, sorry. So it is necessary to properly analyze the scope of affection in advance, check whether it will affect, and finally change all affected source codes at once. So I think traceability is an essential key to specification and design models. So, but traceability is one of the differences to distinguish modeling tools from diagramming tools. So diagramming created by diagramming tools are just pictures. So there is no information about relationships between diagrams, so just many pictures. On the other hand, as I told you, there are many relationships in specification and design. So we call it traceability. So it is impossible to define these relationships between pictures by using diagram tools. In other words, defining and managing traceability in a diagramming tool is impossible. On the other hand, traceability is essential to the model. So this is why a modeling tool is necessary. A model, rather than a bunch of pictures, make it possible to define and manage traceability. I know there are other reasons to use modeling tools, but today I will talk only about traceability. Let me share how to define traceability in Enterprise Architect. So the most basic one would be a connector between elements. I switch my Enterprise Architect to show very basic example here. And number one is by connector, yes, like this. So connect two elements. So when we use UML, we usually use a trace or an abstraction to define traceability. And trace abstraction is in common relationships, toolbox groups here and here. But we can create these kind of connector by using the quick linker. And for some notations such as SysML, special kinds of traceability are defined. For example, SysML defines satisfy or allocate and some other types for traceability. So in such cases, we select the suitable type depending on the relationships. And second, there are also relationships called classifier and types. In this example here, for example, we can use class elements here. We can use class elements as lifeline or object in sequence or object diagrams. In this case, there is a relationship between this class and this object. So this object is typed by this class. And similarly, in SysML, we can define a block element or interface block element and create a path property or port of its type. So here, this is the interface block, and this port is typed this interface block. So there is a relationship between here, but it's not a connector, so we can see in diagram. In addition, we can associate a type with a return value of operations or attribute. Here, class 2 is a type of here. And triggers used in state massing diagrams can be associated with signal. In this case, trigger element type has signal, so we can specify actual signal elements here. And we can connect a signal with an action to specify which signal is received or sent. In this case here, this send signal action has actual signal here. We can specify actual signal here. So there is a relationships between here and between here, but it's another kind of relationships, not connector. And third, another essential piece of traceability information is the placement of elements in diagrams. Switch again here. So in this case, so class 2 is placed in this diagrams. So each diagram has a purpose or perspective. An element placed on the diagram indicate it is related to that purpose or perspective. So it's very important information which diagram each element is placed. And fourth is the created elements are stored in the model browser. So switch to sample again. number 4 here. So the class 2 and the class 3, so these elements is stored here in the browser. Parent-child relationships in the browser are also information related to traceability. In other words, we can know which elements are detailed or related to parent elements by a parent-child relationship. And finally, a tagged value of type ref GUID can define a relationships between one element and another. In example here, this class 3 element has a tag reference. And this reference has a refer to this class 1, and this tagged value is defined here. This type is ref GUID. So ref GUID type can refer other element or elements, one or more element. So in BPA manner, activity elements here have such tagged values. In this case, for example, resources, this tagged value can have one or more resource role elements. So you can set tagged value to store which element is related. So I will tell you later, but by using this map, so this class 1 is placed some diagrams or have a connector, a trace connector to another element, or classifier. So use this instance or tagged value reference, or this here. This is a parent-child hierarchy relationships here. So basically, there are 5 traceability features. And let's look at facilities related to traceability available in Enterprise Architect. 4 facilities are available as described here. There are the relationship matrix and the matrix view of diagrams and the traceability window and the find in all diagrams feature. Using these facilities, we can see and check the traceability of elements in your model. I will show you a bit. So first, relationship matrix is here to show relationships between elements, in this case, class elements in this package. And switch to relationship matrix view. This is a matrix, but elements in these diagrams. And traceability window is here. Click here to we can see the traceability information here. Clicked elements, selected elements, and find in all diagram features here. We can see elements in diagrams, for example, here and here. So this is a classifier, and this is used as type. And Sparx Japan also offer an add-in product called Traceability Suite. This add-in provides powerful and useful facilities for traceability, especially for MBSE, a model-based systems engineering. The add-in has been created by requests from Japanese users who are already defining and managing traceability. I will use this Traceability Suite add-in today demonstration. Please see this URL for more detail, and a trial is also available. So, for example, I already show you the map, our add-in, and there are another add-in. So matrix, our matrix add-in is basically very similar to basic relationship matrix feature, but you can find differences here. So these two are the same target, same package, same elements. So, for example, so hierarchy view with icon, number of connector relationships, and for example, we can add 2 or more element types, or we can add some filter for example, name or cell type, etc. So we can specify a very complex condition to show relationships in elements. So why there are many facilities related to traceability? The reason is we use each facility for a different purpose. First, we use a matrix to check relationships between multiple elements, and the matrix is only supported for direct relationships between the elements of interest. The matrix helps to find elements for which a relationship is missing or does not exist. So that means isolated element. And next, the traceability window or the map provided by Sparx Japan can display multiple levels of detail for a selected element. They are used to dig deeper into the relationships for the selected element. And the find in all diagram facility help analyze the impact if we change an element. We can see in which diagram the element is used. So in what situations the element used. It's very important information when we want to change model. So we can achieve traceability management by using these facilities depending on the purpose and situation. In other words, we do not use any one facility, but we use all facilities and use them depending on the situation. In this slide, I want to share some tips about traceability. The workload to define and manage traceability is high, so it is necessary to have a policy for traceability. First, please consider why we want to use traceability. It would be the best if we thought about the purpose of traceability. Then, traceability should be defined and managed only for limited elements for the purpose. You may think it is good to define and manage traceability for all elements, but actually, the benefits are not worth the cost. And the next tip is to consider how we will use the model. If we use the model temporarily, it is created once and then never is after finished. Traceability is not necessary in this case. Traceability is variable when the model is used repeatedly for a long period. And traceability is more effective for model with multiple layers, such as system as subsystem I showed earlier, and model used for a long period, and model shared by many people. In other words, we need to consider two things: the cost to defining and managing traceability and the benefits we will receive from traceability. And finally, don't define traceability in a complex way. In other words, defining complex traceability among various elements will make the management cost will very high. So in this slide, there are many arrows here. So this means traceability. So it's very complex. So it's necessary in some arrows. So we do not define this kind of complexity and traceability. And traceability is basically useful, but there is a problem with traceability. By defining traceability, we can check the scope of influence and find omissions. But traceability alone cannot find inconsistency in the model. In other words, a model with perfect traceability is not always consistent model, validated, proper model. And here is one example. And this diagram defines the relationships between requirements and logical blocks and logical blocks and physical blocks. And traceability is defined properly between these elements, so we can know they have relationships. But the fact that traceability is defined is not the same as relationships are valid and correct. from traceability, we cannot determine if the design is reasonable. This relationship is reasonable. In other words, it is possible to find if there are any omissions, but it is impossible to judge if the design is reasonable. So in this case, we can understand that these element is not isolated, but if there is a this is allocation connector, so between these two elements, it might be wrong. So that means this physical block must be allocated to other logical blocks. So we need to check if this is correct or not. And so for traceability, from the point of traceability, it's okay, but in the design, model design, so it might not be okay. So one solution is to define not one, but two passes of traceability relationships. When traceability is checked by two passes, and there is a difference in the result, it indicates there is a problem with wrong traceability or a problem with the wrong model. Here is an example of a two-pass model. I quoted this image from my document, minimum MBSE. You can download from this URL. In creating several diagrams in this document, I have structures in this way. So there is some diagrams. And there are two passes from block to mission requirements. So the two paths allows us to see if there are any problem. For example, when tracing from a particular block here, elements to mission requirements, we can check if the block leads to the same mission requirements via each path. So this red box at the top is a path from the writing mechanism, this block, to system requirements and then mission requirements. And this blue box is a path from the block and then use cases and finally mission requirements. So this blue arrow, and this is a red path. Since these are same model, so same source, so they must lead to the same result. So one block element must eventually lead to the same requirements, same mission requirements. But in this example, our requirements that appears in one path here, control in weather forecast, this mission requirements does not appear in this red box. In other words, we find a problem with the model content or traceability definition. So there are two mission requirements. So these two requirements are appeared here. So this is two, this is one. So this is the difference. So there's a problem. So I want to see the same actual model here. For writing a mechanism, this block to check using traceability map. So we can see the relationships, traceability information. And we can see actual usage. For example, this actions this is used here. So this is related because this parent is partition, activity partition, and activity partition is typed by writing a mechanism. So there is a relationship, so traceability in this case. So I check this use case and this use case. So there are two mission requirements, power outage and control in weather forecast. And from this second path, system requirements, and we can find the power outage here and here, but there is only one mission requirement. So there is a difference. So and there are two mission requirements, but only one. So there is a problem. So maybe we need more traceability information in this path, or sometimes this relation or this relation is wrong. So one of these should be deleted wrong. So anyway, we can find relationships like this. So we cannot find such a problem in the case of one path. So we can check the traceability of or the model validity by two or more passes. But I think more than three passes increase complexity, and the cost of defining and managing traceability outweighs the value. So I think in my experience, two passes is the best. Finally, I want to share today's summary. Traceability is one of the key differences to distinguish modeling tools from diagramming tools, and it requires using the suitable facilities to know or investigate a model. And traceability can be very complex depending on how it is used, and it can be costly and ineffective. So it is necessary to consider how to define and manage traceability. We need to consider the scope of traceability. And finally, in the case of one-pass traceability, it is impossible to validate the model. So if possible, consider we can define two passes of traceability. Two passes of traceability can help in validating the model. And thank you for your joining my session. If you have any question, idea, or anything to discuss, please post them on Microsoft Teams Sparx Japan channel. And I already uploaded this slide. So if you are interested in details, so please download from this channel. And once again, thank you to all Global Summit team for giving me a chance to have a presentation today.
Thank you so much for a valuable session, Takeshi, and thanks to everyone for your time during this session. Hope it is very informative and gave a deeper insights into the topic. So now Takeshi will be available on MS Teams to have a detailed discussions and answer more questions of via Microsoft Teams, and the link have been posted in the chat window for your reference. So you can use that link to reach out to Microsoft Takeshi. And if anyone is having difficulties in reaching out to the teams, then kindly reach out to us on registrations at eaglobalsummit.com so that we will be able to take it forward for you. So thanks once again for everyone who look, and we are looking forward to hosting and all wonderful sessions upcoming shortly. Thank you so much again, Takeshi. Yeah.
Yeah, thank you very much for everyone. Thank you.